Today I'll be telling you how to make negative indices and positive indices and how to simplify square cube groups to make it easier to fit in an equation. First, to make a negative indice and a positive indice, it's kind of simple. Let's say x to the power of negative 1. This equals 1 over x to the power of 1. And the way this works is every single number is over 1. And if we bring this number to the denominator, the opposite side of the fraction, the indice will become positive from negative and vice versa. So if we bring this x to the opposite side of the fraction, which is a numerator in this case, to the top, the indice will change from positive to negative. Let's say another question like 1 over y to the power of negative 1. This equals y to the power of 1. Same case, all we do is bring this to the top to change the indice from negative to positive. Since it's in the denominator, the opposite side of the fraction, which is the numerator, just making it the indice positive. And now square roots. Let's say x squared root. This is easy. All we do, since in a default root there's always a 2, it's always the power of 2, and then the power of the number is squared, and then the power of the root is 2, so the power of the root always goes to the denominator and the power of the number stays the numerator. So in this case, x to the power of 2 over the power of the root, which is 2, so x to the power of 2 over 2. Doing this makes the indice form and cancels out the root. So x to the power of 2 over 2 is 1. So x, the answer is x for this. And let's just do cube roots quickly. So y squared cubed. This, same thing. This goes to the denominator, and the squared number, which is this number, stays in the numerator. So y squared over 3, which is the answer, and takes out the root. For the first question, the question is asking simplify and leave the answer in a positive indice. Okay, now the first thing I like to do in questions like this is to make the roots into indice form to make the question easy to solve. So over here, there's always an invisible 2 since it's a default root, and over here there's already the 3. So 4 is to the power of 1 over the root, which is 2, times x to the power of negative 4 over 2 to the power of negative 1 times x, the number, then the power with the number, which is 3, and the root power, which is 3, which gives us 1. And then the next part of this question is to simplify. And to simplify this, the second index law states that if the bases are the same and if it's division, we can minus the indices, which is minus 4 has to be minus 1, which is minus 5. So it's 4 to the power of half times x to the power of minus 5 over 2 to the power of negative 1. So the next part of this question is to make the indices positive. To make the indices positive, the x indice is negative and the 2 indice is negative. So to make the x indice positive, we need to bring it to the opposite side, which is the denominator, and the 2 indice positive, we need to bring it to the opposite side, which is the numerator. So 4 to the power of half times 2 to the power of 1, since it became positive, x to the power of 5, positive now. And now simplify to the best of our ability. 4 to the power of half is 2 times 2 over x to the power of 5, which will give us 4 over x to the power of 5, the final answer. The last question is simplify and leave the answer in a positive indice. Okay, the first thing we do here is make the root into an indice form. So 2, x to the power of negative 2 over 2 is negative 1. And then we make the big root, raise the power for the big root and all the numbers inside. So 9 over 3 times y 5 over 3 times x negative 1 over 3 over 3 over 3 times y negative 7 over 3 times x 4 over 3. And then the next step I do in this question is bring this y next to the top. Some may think this step is useless, but this step is very helpful. So 9 to the power of 3, since 9 over 3 is 3, times y 5 over 3 times y 7 over 3, since it was negative, bringing it to the top makes it positive, times x negative 1 over 3 times x negative 4 over 3 which equals 9 over 3 is 729, and the index law states that If the base is the same, we can add the powers. So y 12 over 3 times base are the same, we can add the powers. So -1, -4 is x, -5 over 3 over 3, which this gives us answer, which leaves it in positive indices. We need to bring this x to the denominator since it's negative to make a positive. So 729 y to the power of 4 over 3x to the power of -5 over 3, and that's the final answer.